In this lesson, we will discuss atmospheric density in standard atmospheric conditions. It is not all-inclusive of everything we need to know for this course. Additional information can be found in FAA publication H-8083-30. Because lower air temperatures usually indicate higher air density, we might assume that as the air temperature decreases with increasing altitude, that air density would increase with increasing altitude. However, the opposite is true. Both air temperature and density decrease as the altitude increases. Humidity lowers atmospheric density. Humid air is less dense at a given pressure and temperature than is dry air at the same pressure and temperature. Air density affects aircraft performance in two main ways. First, less dense air results in less lift being produced by the wing. Secondly, less dense air degrades engine performance by making less oxygen available for combustion in a given volume of air. Humidity not only decreases air density, but the water vapor also displaces some of the oxygen. Absolute humidity is the actual amount of water vapor in a mixture of air and water. Often expressed in pounds per cubic foot, the amount of water vapor that can be present in the air is dependent upon the temperature and pressure. The higher the temperature, the more water vapor the air is capable of holding. When the air has all of the water vapor it can hold at the prevailing temperature and pressure, it is said to be saturated. The relative humidity is the ratio of the amount of water vapor actually present in the atmosphere to the amount that would be present if the air were saturated at the prevailing temperature and pressure. This ratio is usually expressed as a percentage. When the weatherman tells us the humidity is 90%, he is giving us the relative humidity. The dew point is the temperature to which humid air must be cooled at a constant pressure to become saturated. At the dew point, fog may begin to form. The dew point is an important consideration of pilots. When planning a flight, if the weather forecast indicates the outside air temperature is approaching the dew point, the pilot must be aware that fog may form, possibly reducing visibility to zero and preventing the flight from being made under visual flight rules. The fraction of the air pressure that is due to humidity is called the vapor pressure. Because the performance of an aircraft varies widely with different temperatures and pressures and humidity levels, some standards are set to compute and compare aircraft performance. Standard atmospheric pressure at sea level is 29.92 inches of mercury. Standard temperature at sea level is 59 degrees Fahrenheit, and the standard gravity at sea level is 32.174 feet per second squared.